In this video, I'm going to show you how you can process the model you train with MobileNetV2 when you did some transfer learning and see what we can get from it on the images we already tried to classify with the MNIST architecture. So let me go back to my folder here. So that corresponds to results I got before, and we saw that it was not classified as normal, so it wasn't working well. We're going to add a new folder that I'm going to call the results. Open the running MobileNetV2. Then we're going to define the parameters. So that's actually, it's the same parameters as with the other model. We're just going to change the model. Okay, so input directory, it's in test. We have these two images, one normal tissue, one adenocarcinoma tissue. Here I'm going to select the MobileNetV2, and in that case, I'm going to use the one with 1E-4, so that's the one that gave us the best results. And here, results transfer learning. So we have 3 channels, 2 classes, 224, 224, and score, which actually is the image scores, and then I'm going to clean without the image score, just the files. So we have 2 files, 2 images, and the file. So if I open the normal, that's reassuring because this is a class, first class corresponds to normal, and most of them are bright and black in the adenocarcinoma. So probably it's better with a job. And here, when you look at the scores, clearly it's 81% for normal, 18% for adenocarcinoma. So here, the classification is right. And if I open the second one, now that's the other way around. That's mainly dark for first class, mainly bright for second class. And so if I open the file, that's the exact opposite. It's 14% for normal, 85% for adenocarcinoma. So here, classification is correct. So obviously that that's it's not enough to conclude. It would be a much better method to go through a lot of images and to validate on lots of images. Also, the training could be improved. We saw that we could increase the number of epochs. We could also maybe try to train other parts of the architecture, maybe the last block as well, maybe the whole architecture. Even though I made a few tests, and it seems that using the pre-trained model is much better. Just sticking to the last layer seems to lead to better results. But we could have more epochs, and definitely we could do some data augmentation as well, and it should improve the performance. And we'll see that in the next training. What is interesting as well is that we see here we do image classification, and yet it's to be a segmentation. If we go back, so I'm going to go back to the image, which is there. We can see which toys lead to the decision. Here, everything that is dark is considered as so it's dark for adenocarcinoma, so it's bright for normal. So these toys seems to lead the decision. When we look at the the dog ties, it's the ties that are outside. So that's interesting. This should be maybe in a very well-trained model. It would be great for both classes because shouldn't make a decision based on this part. And here, so which seems to be muscles. It shouldn't be the case. But by doing that, it's interesting. It's you start to do some segmentation as well. Which toys are closer to normal tissue, which toys are closer to adenocarcinoma tissue. Something else that could be done here is maybe to increase the size, because we see that we need more context. Now, as we use transfer learning, we cannot change the size of the toys, but maybe we could play with the resolution to have lower resolution. We would have more context, and maybe we would make better decisions.